Why, hello there everybody! Welcome to my passion project video. I made a video so you could decide if you wanted a headache or not. But since you're here, let's hop into the video. Let's first start with how elements are made. Elements are made of atoms, which are made of protons and neutrons. No, not that neutron. There we go. Anyway, all those protons and neutrons together make what is called a nucleus. The nucleus attracts electrons into its orbit with its negative and positive energy. Like this. The amount of electrons there are in an element depends on how many protons are in the nucleus. With all the electrons circling around the nucleus, it makes shells, or rings, that circle around the nucleus. These shells can hold a certain amount of electrons. The first one can hold 2, the second one can hold 8, and the third one can hold 18. If all the shells are full, no more electrons can be added in. Let's start off with our first compound, water. Water is made with 2 hydrogen and 1 oxygen. Oxygen on its own can hold 8 electrons. But from what we've learned about shells, 2 more electrons can be added in. Now for hydrogen, it can hold 2 electrons, but on its own it only holds 1, which means that there's room for more electrons. And because there's 2 hydrogen atoms, the required 2 electrons can be added to the oxygen atom, which would look like this. And that's how water is made. Next, we're going to talk about carbohydrates. Carbohydrates are made from 2 hydrogen, 1 oxygen, and 1 carbon. Carbon holds 6 electrons on its own, but from what we've learned about the second shell, it can hold 4 more. But for all these elements to come together, I have to teach you something that I haven't taught you yet. Let's use H2O as an example. Now with water, if you add all the hydrogen together, water becomes full, but there is still a way to make room. If the oxygen atom wants more hydrogen, it can send electrons to the hydrogen bonds that are already on it, so more hydrogen can go onto the oxygen atom. Now, where were we? Oh yeah, carbohydrates. Now, if you put all the hydrogen on the oxygen, it will send all the electrons to the hydrogen, so then it could combine with carbon. And now, I think it's time for the next logical step. Now, let's talk about the next logical step, explosions on the sun. But first, let's talk about how the explosions start. The explosions start at the core of the sun. The core of the sun is filled with hydrogen, and with all this heat and pressure from the sun, it turns that hydrogen into helium. But this isn't any normal hydrogen. These are 2 special hydrogen atoms. See, if you add 2 of the same elements together, it should not equal another element. But with enough heat and pressure and isotopes, it can. You may be wondering, what's an isotope? Well, an isotope is what you describe an element that can have more neutrons than protons. The isotopes we'll be focusing on is the isotopes for hydrogen, which is protonium, deuterium, and tritium. We want to focus on deuterium and tritium because that's what's in the core of the sun. When all those elements get compressed into helium, it becomes unstable and falls apart, releasing radiation. And that's what makes explosions on the sun. You may be wondering, well, how powerful are these explosions? Don't ask me. It's so big. It's so big. The explosions are so big, I don't understand a word this is saying. Don't ask me, please. And this is the end of my passion project. I hope you guys all enjoyed. Okay. This is the end. Bye.